Platte angeschlossen?
Already recording. Hello and welcome. It's been a long while.
Yeah, it's been a while. Probably due to you being in Portugal again over the winter time.
Not my blame. No. We had stuff to do and places to be, so yeah.
And now we're here again.
We're here again.
And a lot of things happened in the meantime. One of the things that happened is displayed here. MLOPs or MLOPs or what is this?
MLOPs.
MLOPs. I mean, first I have to say congrats for the logo. The logo is artwork originally by Moritz, and it is just fantastic. I think from the logo you can infer the meaning of artificial intelligence for computer graphics. Everything is so much nicer now and so much easier to do, right?
If you'd be mean, you could say I stopped caring at some point.
Probably. No, it's yeah. Let's first explain what this is, because today's episode is about MLOPs, right?
MLOPs, yeah.
And I will try to explain it.
Okay, please.
Because I only got half of it, I think. So if I understood this correctly, it is a project by us and Tagma, so you, because I'm not involved, and Ambrosiusen, Paul Ambrosiusen, who used to work for Side Effects.
Correct.
With the game, he's responsible for parts of the game tools, or for big parts of the game tools.
Now
I think.
labs, yes.
Labs, right? And now he is on his own doing consulting.
Consulting, so you can hire him as a freelance technical artist.
Which is great because he's a very talented.
He's
young
crazily talented. He's just,
guy.
it's insane.
And he and you decided to pitch a project at Side Effects to implement what is actually the open source part of machine learning provided by Hugging Face.
Yeah, you could say it like that. So yeah, the project originated with us just being stupid and just giggling around and saying that it would be funny for Side Effects to send us to Monaco.
Yeah.
And back then we were just trying to justify it with something Monte Carlo method. And then when actually...
Monte Carlo method in Monaco, ha ha.
Yeah. So actually when Side Effects decided to go ahead with the project, we had to come up with an idea, and at this point Monte Carlo method was kind of old school, so we looked around and found...
Monte Carlo method is old school. That is what scares me. Every day new advancements in machine learning make the Monte Carlo method old school.
I mean, Monte Carlo method is 40s, right?
Yeah.
So
that's young in scientific terms.
Yeah, in math terms, definitely. Now,
I mean, all the machine learning stuff goes back to the 40s too. The first proposals for the perceptron architecture date back to the 40s.
Was that 40s? I thought 50s, but yeah.
This conference took place in the 60s, but I think the first ideas where the structure was formulated goes back to the 40s, if I'm not mistaken.
Okay.
It's not that young either. It's just that we now have the compute power and the data.
So back to the story. We have to look around and just try to come up with some topics that interested us. And machine learning was high on our list. And a few weeks before we had this discussion, I found the Diffuses library, which is a library by Hugging Face, which abstracts away a lot of machine learning when it comes to generative images. So we decided on implementing that and bringing that into Houdini.
Okay, because that was my first question. What is this actually? And from what you say, if you want to try to dig into machine learning, you would use a Python interpreter and maybe this Hugging Face library. That is for people that do not want to get their hands dirty with PyTorch and stuff like this, where you can implement everything from scratch.
That's correct.
And if you don't want to do that, but still you want to create custom stuff with machine learning, you might want to use this library. And because you don't want to use Python coding, you decided to wrap this as Houdini nodes, right?
That is correct. So what you can do, Okay, let's start from the beginning. So Diffusers is a library developed or maintained by Hugging Face, which is the hub to share machine learning demos, who are hosting some checkpoints, some trained models, and who also run a cloud compute service where you can pay a bit of money to run your demos in a decent quality. Diffusers is their library that implements not only Stable Diffusion, but a bunch of other pipelines. And they do a really great job at allowing you to modularly build those pipelines. And they can use the wholly abstract pipeline libraries, which is just like, which allows you to infer an image within like 3, 4, 5 lines of Python, typically done in a Google Colab. Or you can dive in there and build your own pipelines as intricately and as complicatedly and as detailedly as you want.
So you can dig as deep as you like.
Yeah.
So if you want to really change some part of the pipeline,
You can do that.
you can.
Yeah.
So it probably starts, if you are interested in machine learning, that you just try something out where machine learning is just nicely packaged,
Just a
like
black box.
I don't know, Midjourney.
Yeah.
And then you want more. You'll probably want to put in some control images or whatever. Then you see this is only possible to a certain extent with Midjourney. Then you might want to switch to Stable Diffusion. And you might want to use something like a web GUI or something like that. And if you want to dig even deeper, then you get to MLOPs.
You perfectly described the descent into madness.
Okay, that
typically
is
takes
actually great. So it takes away all the pain of learning all this Python stuff.
place. Most of the Python stuff.
There is still Python stuff.
Of course. I mean, the default thing that you get when you're working in Hugging Face and working with diffusers is a collab that they set up as a demo. Usually really readable, usually only high-level Python, so you don't have to occupy yourself too much with which slice of a NumPy array you now have to feed into this thing.
And that is a pain.
It is. But also ChatGPT to the rescue when it comes to NumPy slicing. ChatGPT is really good solving that without bullshitting you too much.
Okay. Good to know.
So yeah, and also we stumbled upon a project which is called ComfyUI. So typically what you described, the first GUI that you find for Stable Diffusion is called Automatic 1111 Web UI, which is a really nice GUI that you can host on your own computer, runs in the browser, has your typical web interface where you can do prompting, where you can manipulate seeds, add a bunch of plugins to it. But it's usually a rather high-level overview of the whole process. And if you want to dive deeper, there's another UI for it called ComfyUI, which kind of dissects the process into individual nodes, such as a prompt creator, a tokenizer, a solver.
So that means that there is this algorithm called Stable Diffusion,
Yes.
and it is made up of individual parts,
Yes.
and the data structures are individual parts. You have different UNets and stuff in there, right? And with this UI, you can tackle individual tasks. Sorry, you can customize the behavior of individual parts. You can pull out the data probably from individual stages and do something with the data. Okay, that is great.
So that's the valuable part within Houdini. So what kind of annoyed me when using WebUI is a really nice thing. What kind of annoyed me, if you wanted to do something custom, you were down to doing your own Python script, which is absolutely doable. You just have to go through their libraries again, see how they interface with their pipelines, and then manipulate the data they pass between those individual
With the WebUI,
components.
you are using the WebUI library.
So they are building upon diffusers as far as I got it, but also they have their own processing library, which they call process. So you pass this a few arguments, and then you can wrangle the data they pass around with their individual modules. Yeah.
So other than not having to write as much Python, what is the big advantage of having this wrapped inside of Houdini as nodes?
So the thing with Python is as brilliantly as it is, it's particularly bad when working with image data, when working with three-dimensional data. Got lots of boilerplate code. The interface that you get with interacting with those data is kind of questionable, let's call it that way. It's very scientific, very much for geared towards scientific visualization, and it's very good at that. Just for content creation, it's not maybe the most accessible thing. So what we allow with MLOPs is not only manipulating the data that flows between the different stages, the different components of a diffusion pipeline in a Houdini way, so it's all point attributes. We also allow manipulating and working with the results of that. So for example, what you can take is you can use a viewport rendering of some geometry, feed this into a control net, use it to generate a quote-unquote rendering or whatever you want, and then projecting it back onto the object as a 3D texture and then work from there. And that is kind of tedious to implement in Python and kind of tedious to work with in Python. So yeah, that's the advantage, having all that data structures in a way that you can easily manipulate it.
And you, if I understand this correctly, you convert the data to Houdini geometry data.
Yeah.
So there is this tokenization and then these word embeddings. And in theory, you can project down the word embedding space to 3 dimensions and use this as point data. If you
Exactly.
want to.
For example, that's what we do in the current node that we released with this new release, which is called bidimensionality reduction, which implements UMAP, which is a way of projecting those highly dimensional vectors that word embeddings are with 512 or 77,000 components into a 2D or 3D space. So you can kind of cluster them and see where they live in latent space.
Okay. That sounds fantastic because on one hand, I can imagine that it is a lot easier to understand what's actually going on if you have this process split up into parts, and if you can really see the results of individual parts and inspect what actually is happening there. So as a learning tool, it's probably a good thing to use. And then on the other hand, you can just abuse the data, and that is what we always did with Entagma: abuse the data for just stupid visualizations of whatever. Right?
Exactly. Those are the main 2 takeaways, actually. On the one hand, understanding what are the components that make up Stable Diffusion, but also with the recent release, we have a monolithic node. So if you don't care about this and just want to prompt something, you can also do that with a single node, which is just an encapsulated HDA of what we built under the hood, but also and mainly manipulating the data. Yeah.
Fantastic.
I hope so.
What is the community doing with it?
We've seen lots of effort going into the texture workflow. So we are seeing lots of HDAs popping up with a semi-automatic or automatic way of texturing whole 3D meshes, not only from one camera perspective, but inferring textures from multiple camera perspectives, making sure they are consistent and reprojecting them back. So typically if you have your non-textured object and just prompt for, I don't know, if you have your horse head and prompt for a texture of a horse, it automatically creates that, projects
Wait
it back.
a second. That means I'm building a sci-fi robot and it is gray, and then I just say, I don't know, it consists of 25,000 parts, and I can say, texture this for me.
Yes.
And then you can pass on a prompt of what you want to see, like rusty bolts or whatever, and it textures the object just with one click.
Yes.
That's actually nice.
Yes. And with ControlNet, you can also add control nets that, for example, control the color palette of it. So you don't have to manually prompt for a certain color palette or dial in the seed until you like it, but you just give it a bunch of pixels from which it reads the color palette it should use for your sci-fi robot.
And where can people get these HDAs? Where are they usually posted?
So when you go to our GitHub or our webpage, which is bismuth.at/MLOPs, link in the description, we have a link for Discord there, and the Discord is really active. And if you join the Discord, you can find a thread in there where people post their custom HDAs that they build using MLOps.
So far, everything for free?
Yes, everything for free. The thing is open source. So if you want to develop it, if you want to expand on it, feel free to download it, branch it, build on it. Yeah.
Nice. Interesting. And if you have no clue about machine learning whatsoever, is there a way to get started with this easily? Do we have tutorials so far for MLOPs?
Yeah, we do have tutorials for MLOPs. We cover the basics of building your first Stable Diffusion tree. We also cover how to actually render out your viewport. We have a nice utility node for that does kind of real-time rendering of your viewport, which is also helpful not only if you're using machine learning, but for any other case as well. We've got tutorials covering that. Yeah, we have, I think, 5, 6, 7 videos out by now. Exactly. And if you want to get a general idea of machine learning, it's still good to have a look at WebUI, Automatic 1111, or Comfy UI.
Okay. So, is this the future? Is this the game changer that everybody's talking about?
I think we're at this typical hype cycle now, and I think we're still on the rising flank of it. We haven't reached it yet.
So we are ascending Mount Stupid.
Yeah, I'm not sure if you want to call the first peak of the hype cycle Mount Stupid, but I think also what you can see with NVIDIA stock, I think we are still on the rising flank of the hype cycle. We see lots of rather simple takes on the AI on Twitter, where people say this is the end of Photoshop, this is the end of XYZ. It clearly isn't. It's a highly interesting tool that will fundamentally change how we work, but we are seeing some unrealistic takes on it.
Mm-hmm.
What was the question again?
If this is the future, if it changes everything, if we can just, basically the question, or what I was intending with the question is, can we stop learning computer graphics as we taught on Antagma for the last 7 years? Or because everything will change and everything will just be machine learning in the future? Or is it a coexistence and just another tool in your tool bag?
So can we stop learning computer graphics? I think certain parts we can stop learning, and certain parts will be replaced by automated algorithms, I hope. But those are the tedious parts that in reality...
Like UV mapping.
Yeah, exactly. That would be my first example. UV mapping. No one wanted to do this. Rotoscoping, stuff like that. Segmenting stuff. Why on earth would you? Stuff like that we can stop learning. I think it's still beneficial to understand where we're coming from. It's still beneficial to understand the logic behind computer graphics. It's still highly valuable to be able to break down a problem into individual logical steps to formulate your algorithms. Because although still we're seeing large language models such as ChatGPT rising, they are still particularly bad at solving more complex problems, and they bullshit you into this is your proper code that will run. So it still takes a bit of expertise, a bit of understanding to bug fix what they output.
Yeah, that is my finding too. I tried to use ChatGPT to develop some Blender add-ons using Python and NumPy, and while being very helpful, you have to be able to understand the code, otherwise it will not create something useful for you. If it is not the very, very simplistic case, it just usually creates errors. Yeah. Still, it is valuable because for me, it serves as a replacement for the documentation sometimes.
Absolutely.
Because it is able to explain how it actually is meant to be used, and that is very valuable. But if you have the impression, or if you have the hope that you could just put in a text prompt into ChatGPT and it will output a running program in Python, that is usually not the case.
Not yet.
We will get there, maybe.
I assume, yeah.
Okay, that is interesting. My question regarding what computer graphics knowledge is, well, all this machine learning stuff is highly dependent on linear algebra, and computer graphics is too. So how much linear algebra understanding do you actually need to get what this is doing under the hood? If you want to dive deep, if you want to dissect the algorithm into individual parts, do you actually have to understand what's going on, or is it enough to have your personal interpretation of a high-dimensional space?
I think it's rather the last thing. So especially with diffusers, you're not going to the nitty-gritty. You still have your modules that are hiding away the really rough details of linear algebra. You can, of course, as an academic exercise, build your own neural net, doing all this stuff manually, but nowadays you're rather working with high or intermediate level libraries. So having a more intuitive understanding of what's going under the hood, and maybe reading 1 or 2 Medium articles, or watching a tutorial on the basics of machine learning, such as, for example, by 3 Blue 1 Brown.
Excellent series.
Yeah, excellent series. In my opinion, is enough. If you're not planning on building a neural net from scratch yourself.
So building a neural net from scratch as an academic exercise is probably like creating a ray tracer just for fun with VEX on geo level in Houdini, just to see, well, it's working, and I got a principle by doing this. I mean, it's not usable.
It's very valuable if you want to understand the principles behind it. But I think until you get to the point where you might have the ambition to do so, you will be using more intermediate or high-level libraries for a long time.
Nice. Now that we have this inside of Houdini, everybody can use it and dive as deep as they want, right?
Absolutely.
That's fantastic. Yeah.
One thing I'd like to add, because we're getting a bit of feedback that goes into this direction, is why is this useful, or why should I use this, or why should I use this over Photoshop? You shouldn't use this over Photoshop. If you're happy doing your 2D images and doing your inference in Photoshop, by all means do so. Why is this useful? If you are working in a 3D pipeline that needs adaptability, if you're working in a 3D pipeline that you want to integrate new tools in, this might be the most modular, most accessible in a intermediate way pipeline. So accessible in the way of you being able to mingle and mangle and wrangle data that goes between all of those and still be able to customize the output. So for example, most plugins for Blender so far I've seen do this on a very high level, very well.
One button like here, there's a prompt and
exactly. But if you want to customize your machine learning setups, but in an environment that is heavily geared to 3D animation, to media production, and that you might be used to, I think this is your best bet so far.
Mm-hmm. So in a way, it's, if I can invent this word, sort of very Houdinistic, because I have the feeling that Houdini is, or used to be doing this all the time, like getting complicated concepts, wrapping them up in nodes, but not build a monolith, instead give you modular access and access to the intermediate data, like with the, I don't know, geodesics distance, shortest path node. It's a very complicated algorithm and it outputs just data, geometry data that you can use for whatever. Yeah. And in this sense, it's a very nice addition to Houdini, I think.
And it comes with the same upsides and downsides as the Houdinistic approach itself. On the one hand, it allows you to be very flexible, very modular. On the other hand, it might not be the super fast approach if you just like need your one image right now. Mm-hmm. You're still going to go into WebUI or Midjourney or whatever you need for that.
Or you start building your own HDAs and just keep a library of high-level tools around that you can use.
Or that.
Fantastic. So a little bit future inside of Houdini, if I can say that.
I wouldn't say future. I would say contemporary.
Yeah, or present. Yeah, the future will bring even more fantastic stuff. But I get the impression, especially with a library like this or with a package like this, that machine learning is not changing everything and it will not replace everything. It's just one very impressive part of a pipeline and will give us more flexibility, more tools to approach things faster and more effortless. And in this sense, I think, is it a good idea to give the suggestion to everybody to look into this?
Absolutely. It doesn't have to be MLOps. It can be Automatic 1111. It can be Comfy UI. I just would highly recommend to not stop at just using Midjourney.
Yeah.
I would recommend of getting a deeper understanding of what's going on there and getting a wider overview of the tools that are available there. For example, just to finish this off, not only is the inference or the creation of image a rather interesting part, but also in MLOps we have additional tools for automatic image segmentation, where you can draw masks over the whole images or manually select them, for background removal, for automatic creation of depth maps. So you have a lot of auxiliary tools, or for upsampling, upresing images. That are based on machine learning.
That is very interesting. That means that this tool set is very useful beyond the bounds of generative images.
Absolutely.
You can use it for texturing. You can use it for photogrammetry pipelines.
Yes.
You can use it for whatever.
Yes.
It is not. And I think this is a misconception with many people, that this is just for putting in an astronaut riding a horse and then getting an image back. No, not at all.
No,
it is
absolutely
just
not.
A bag of algorithms
based
on machine learning instead of based on Monte Carlo.
Yeah, that's it.
That create useful data that we can use for whatever.
And maybe to project this for the intermediate future or the next year, what I'm expecting to happen in the ML space is, on the one hand, we will see more and more generative 3D based models, which Houdini, in my opinion, is the perfect perfect environment to use those in. So looking very much forward to seeing those come up and maybe able to implement them into MLOps. And the other thing that I think we're going to see is the rise of temporally coherent models, also in an open source space, so that we are able to infer moving images.
Mm-hmm.
And I'm
Very
looking
interesting
very
too.
much forward to being able to implement those in MLOps.
Thanks for the info, Moritz. I have two more questions. The first one is, you talked about checkpoints that you can download from Hugging Face.
Mm-hmm.
And I was always wondering, where do these come from? Who actually trains them? I mean, you need a lot of money, a lot of GPUs, that is,
Well, not
for
anymore.
training them.
Okay, so not anymore. So there is these foundational checkpoints, such as the Stable Diffusion 1.5 or 2.1 checkpoints, and they are usually trained by larger organizations that can afford the computational cost of those. So they are trained from scratch. However, based off of these checkpoints, it's rather easy and computationally not that expensive to modify those and adapt those to your needs. And
So if you want your face in there.
if you want your face on there, if you want a certain style, it's easy to, or easier to create those. And those are typically trained by individuals. And you can find those on Hugging Face or on Civit.ai, which is a large library of those custom trained checkpoints. There's a surprising number of, let's call them interesting checkpoints, where, yeah, they are trained on topics that I wouldn't necessarily spend computational power on.
I think I get what you're trying to say.
But there's a wide variety of also very interesting checkpoints.
Okay, so let's explore the interesting checkpoints. And my last question for today is, will you continue working on this? Will this be supported in the future? Or is it now a state where you say, community, take it, do whatever you want with it?
In generally, we already say community, take it, develop it further, while maintaining a certain code quality and code standard. And I mean, I'm to blame for this myself. I always have Paul Ambrosiusen just slapping me on the wrist and saying, no, not like that. But there is a third sprint at least planned with this later in the year.
Okay.
Hopefully then we will be able to see some of the models that I teased on being released and we being able to integrate those. There is at least one more sprint planned from our side, and so far we both, Paul and I, are very eager to develop this further. That being said, we are dependent on people chiming in, this becoming open source more and more, having the community also chime into the development, and Paul just being the gatekeeper of good code quality.
Thank you, Paul.
Thank you, Paul. Yeah.
Thank you, Paul. Good code quality. That is something we did not have to deal with in the past.
No.
That is, by the way, a lot of people say Vex is complicated, but what Vex allows you to do is write shitty code and it still works.
Absolutely. I mean, Python also allows you to do that. It's
Yeah, but then it usually fails. With Vex, it's not that easy. I find Vex being so much easier than Python.
Yeah. But that's a whole different discussion, which maybe we should have in another node round.
Probably. Absolutely. So please, people from the internet, expect to see more machine learning related content on Antagma,
Yes.
as we strongly believe, both of us, that this will be a big part of the future of computer
Absolutely.
graphics. So it is necessary to talk about it,
Yes.
and it's necessary to learn about it.
Yes.
We will have classical content too, because it is important to understand the principles. It's necessary to make yourself familiar with working with data, understanding data structures and algorithms and all of that. So whatever you do, learning computer graphics will not be wasted. It will
Absolutely.
help
And
you understand all of this.
Antagma won't transform in a purely machine learning channel.
No, not at all. It's just one more tool. It's
Yeah.
like you did the series on Vellum because it is, PPD is just an important concept nowadays for simulating stuff. And now we have, one route going into machine learning, and I enjoy this a lot. Thank you so much for the information.
Thanks
It
for the
was
discussion.
important for me because I'm having a hard time keeping up at the moment because all this academia stuff that I'm doing
Before we say goodbye, I think that's mainly due to your approach of trying to understand the fundamentals first, which in this case, as you have so many waves coming in with the AI. I think in this case, it's more apt to just have a go at it, try to work their Colab examples that they have, and then from there, just try and understand what they do under the hood. I think that's more approachable and a bit more efficient.
So instead of learning everything, just use it.
Use it and then try to understand what's going on under the hood instead of trying to grasp linear algebra first and then going into the Colabs.
Absolutely. Nevertheless, if you want to dig deeper into linear algebra, I can, as always, recommend Khan Academy. And especially with linear algebra, they did a collaboration with 3 Blue 1 Brown, actually.
Cool. Very cool.
So if you want to do that, even that is possible. Thank you so much, Moritz, for
Thanks,
being
Manu.
here. I hope that we can continue these conversations on a more regular basis again in the future.
I think so.
Hopefully so. And then it is cheers and goodbye.
I think so. Goodbye, guys.
Cheers.